the mole, mass and volume relationships. Mr. Chardon's Period A honors. I am Pat Dion, the producer. The rest of the group is Alex Cambio, Brooke Foster, Mike Pisano, Mike Caprini, Kevin Crowley, and Taylor Boyer. The questions we will be going over today are how to convert the mass of a substance into the numbers of moles in a substance, and also how to calculate the moles of gas in a given volume at STP.
Hi, I'm Mike Pisano. Hi, I'm Kevin Crowley.
Hi, I'm Taylor Boyer.
We are converting moles to mass, and we have to calculate the mass of 2.50 moles of iron 2 hydroxide. So our given was that, we're trying to find grams of iron hydroxide, and that's the symbol for it. And our given was there's 2.50 moles of iron 2 hydroxide, and then you times it by the fraction of 89.96 grams of iron 2 hydroxide over 1 mole of iron 2 hydroxide, and final answer of that would be 224.65 grams of iron 2 hydroxide.
We are converting mass to moles and trying to find the number of moles in N2O3, which is dinitrogen trioxide. So you take 75.0 grams of N2O3 times 1 mole of N2O3 over 76.02 grams of N2O3, and that would equal 0.99 moles of N2O3.
Good job.
Calculating gas quantities at STP. Sulfur dioxide is a gas produced by burning coal. It is an air pollutant and one of the causes of acid rain. Determine the volume in liters of 0.6 mole SO2 gas at STP. The knowns are the number of moles, which is 0.6 mole SO2, and 1 mole SO2 equals 22.4 LSO2. The volume is unknown.
One mole of any gas at STP has a volume of 22.4 liters. So, a 0.60 mole should have a volume slightly larger than half the mole, or 11.2 liters. The answer should have two significant figures.
Calculating molar mass and density. Different gases have different densities. Usually the density of a gas is measured in grams per liter at a specific temperature. The density of gas at STP and the molar volume at STP can be used to calculate the molar mass of the gas. The molar mass of a gas and the molar volume at STP can be used to calculate the density of a gas at STP. Calculating the molar mass of a gas at STP. The density of a gaseous compound containing carbon and oxygen is found to be 1.964 at STP. What is the molar mass of the compound? The knowns are density, which is 1.964 grams per liter, and 1 mole of gas at STP equals 22.4 liters. The unknowns are the molar mass, which is going to equal something grams per mole.
This answer makes sense because the molecular...
As he was saying, this makes sense because the ratio of the calculated mass to the volume is about 2, which is close to the known density. The answer should have 3 significant figures.
Use the molar mass of an element compound to convert between the mass of the substance and the moles of the substance. As you can see, molar mass equals 1 mole. To find the mole to volume relationship, we use Avogadro's hypothesis, which states that equal volumes of gases at the same temperature and pressure contains equal numbers of particles. Gases vary with change in temperature or change in pressure. So we use the standard temperature and pressure which means a temperature of 0 degrees Celsius and a pressure of 101.3 kPa. At this standard temperature and pressure, 1 mole or 6.02 times 10 to the 23rd representative particles of any gas occupies a volume of 22.4 liters. The quantity 22.4 liters is called the molar volume of 22.4 equals 1 mole at STP. Molar volume is used to convert between the numbers of moles of gas and the volume of gas at standard temperature and pressure.
In conclusion, the molar mass of an element or compound can be converted to the moles of a substance by using this formula: molar mass over 1 mole and 1 mole over molar mass. To convert the molar volume to the number of moles of a gas at STP, we use the formula 22.4 liters over 1 mole and 1 mole over 22.4 liters.